You went over one thing that it sounded kind of trivial, but to me is not trivial. And you mentioned in the beginning when you were writing your process, you were writing your paper or doing your paper, you had some things in mind you wanted to prove.
Yeah.
And then you had a time frame and you just kind of glanced over, you have to be open to your hypothesis might go right. But I don't think that's so easy. I think that's a very difficult point to reach as a mature adult scientist, to have your baby hypothesis that you invest in so much. You try to do several experiments to see if it works, and it would be very exciting if it works, and then you just see it just doesn't work. So there's naturally, I noticed in myself, a bias that I have to fight. When I see a result that is negative to what I want to see, I have to really fight. There's a piece of my heart that leaves, and I have to say, no, this result is shit, and I cannot believe this if I want to build on top of it. So how did you manage to fight against your own human proclivity to this kind of bias?
It's a very good question, Keenan. And I think it was my supervisor who really just taught me we're doing science. We're not, it's not we're producing something and it's always true. We have to always be open for whatever we do. It might not show what we want. And she always normalized this feeling. She always said it's completely okay. This is what the data shows. And then we move on. It's hard to let go, though. I tried to figure something out. Keenan, I think I tried it for 1.5 years until we said, okay, we're switching course now a little bit. And it changed the story of the paper. It changed a lot of things, but the reality is it didn't work. So I couldn't do anything. And I think it was really the environment that normalized it for me. I was just like, I felt super supported in that sense of, because I know how it is. You really want this to be true. Because you think if this is true, this is just going to be so amazing. And then you want it to be true. And then you're actually also biased. And I think, thinking of whatever you do, having a hypothesis, but just being completely open. Because, even if it's not true, it's still a result. And that's also interesting.
Mm-hmm.
And, the important thing for me, Keenan, in this sense is always like, I'm just saying to myself, I wouldn't say it's generally not true. I would just say the approach I used to test it did show this. It depends a little bit on the context of the experiment, because, so for example, for me, it was like I couldn't make an experiment work really. And it didn't show me the result I wanted, but that doesn't mean if you took a different method, maybe you could have made it work and you could actually have proven my point. It's just about, and maybe with the technology that is currently available doesn't allow you. And maybe, in 10 years, someone will go and do the same thing and be like, I have all this technology now and I can maybe prove it in a different way. So it's just, I don't know. It can be hard, especially if it's very fundamental for your project in order to move in a certain direction. But I think that's something, it's a hard part about science. And sometimes, it's research. So we're trying to search for answers, and they're often different than we expect them to be, which is exciting too, in a way, I think.
Very, very important that you mentioned how your supervisor normalized this feeling that this is what the data shows, and we should not get attached to it emotionally too much. I have a quote. I have two quotes actually that I would like to share now. One is it's kind of our version from my lab, like how my professor normalizes that environment. When he sees data that looks too beautiful, he says, this is too beautiful to be, too beautiful to be true. So we will, so we always joke about, last lab meeting, someone had a very interesting discovery, but experiment needs to be repeated. And my supervisor goes, that's very beautiful, but as we know from the history of the lab, only about 20% of those can be reproduced. So let's keep going. And then another quote was very interesting from a postdoc from our lab. He said, yeah, that's why science is interesting. We tell each other stories until one of them turns out to be true, but most of them we will have to trash. So it's just a bunch of stories that you have to kind of selecting the true stories. All right. So I love that answer. Thank you for that.